Beautiful. Good morning, good afternoon, everyone. Thank you for joining Asoba's second webinar, our end of year, shall we say, intellect dump, just to give everyone an indication of what we've learned so far this year, and what we have developed and where we're going in the next coming time. So just to start off with some house rules, can everyone please just keep their cameras off and their mics muted? For questions, we'll have a session at the end, so feel free to type your questions in the chat, and we'll get to that as soon as the presentation is finished. Also, so just to give you guys a little background of Asoba, so we're a startup who's ending our pre-seed funding round soon, and our goal and mission is to give people in Africa 100% electricity. There's a lot of people in Africa that just do not have access to electricity due to costs, due to infrastructure, due to a whole lot of factors. And with the renewable energy transition, there's a considerably cheaper amount of electricity that's coming online. And our mission is to spread that over the entire Africa. There's a very strong contrast between the amount of energy and the GDP of countries across the world over our history. And so we believe if we can have 100% electricity across Africa, then we can also help people have better lives and more job opportunities, etc., etc. So my name is Dr. Rain. I'll be handling the webinar today, and I am the machine learning and artificial intelligence engineer of Asoba, and I'm also the chief intelligence officer and a co-founder. And I'll be walking us through exactly what we've developed in regards to AI that we're trying to implement within the energy grid to allow for our mission to become a reality. So just to give you guys an overview of the South African energy landscape. So being born and raised in South Africa, I've got quite a strong history with all of our load shedding and all of our energy problems that we've had over the years. But these results, or at least this data, came from 2024, and it's still quite shocking to see that South Africa has got over 80% of its energy coming from coal, even though there's this big push of so many IPP projects and big renewable projects. It's still a massive, massive majority. And if I may, I think it's completely and absolutely indicative of how far behind South Africa is compared to the first world by looking just purely at our energy mix. And if you want to get a little bit deeper into the gutters of why this is, the truth and the reality is that majority of our state capture lies within our dirty energy. That's why people are calling it dirty energy. Coal is still very much captured. Coal is still very much making many people lots of money. And so it's very difficult for people to get rid of coal, even though there are so many other cheaper options. The other factor is also load shedding within South Africa. So as you guys know, load shedding has been quite detrimental for South Africa in the last decade or so or more. But surprisingly, in 2024, load shedding all of a sudden abruptly stopped. And there could be many factors to this. I think the consensus is generally that Andre de Ruyter, the previous Eskom CEO, was also almost assassinated, did a lot of good work in terms of building up and fixing all of the broken coal plants. So although we still have a complete and absolute coal dominance within our electricity sector, at least by fixing all of the plants, we all of a sudden don't have any load shedding. Which is great, but at the same time, the prediction is that the problems are going to come back because these coal plants are outdated. These coal plants do need a lot of money to consistently recover and rebuild, and that is just completely unsustainable, especially within the new world where, quite frankly, solar and wind is considerably cheaper, although there are a lot of problems with installing them. So just to look at 2023, so we've got about 3 megawatts of new projects coming online, or at least being developed. They're still taking a little while to come online, but that's considerably less than what is necessary. And majority of these embedded generators are either unregistered. So if you have solar panels on your rooftop, you have an unregistered embedded generation. There's municipal registered projects that are coming online, so that municipalities, instead of buying from Eskom, they can now buy from the renewable farms that are also connected to them. Eskom registered, so Eskom is obviously trying to diversify their mix, although the percentage clearly shows that the progress is extremely slow. And then the majority is through private wheeling programs. And wheeling programs generally allow private customers who are buying in bulk to wheel energy from renewable sources and Eskom at the same time to kind of keep consistency. But that's the majority of our renewable projects happening in South Africa is through private wheeling. But again, I think the takeaway from these graphs is just how small the renewable percentage actually is compared to our dirty energy that is completely destroying our economy and our nature and our earth. So just to look at some predictions. So according to Cresco's energy market predictions, we're going to see a very drastic decrease in coal and an increase in solar specifically, because solar is the cheapest, but also an increase in wind. And then nuclear in South Africa is predicted to stay the same. It's just going to be the one nuclear plant unless there's some changes that happen. And then, yes, the majority is going to be the wind and the solar. But there are lots of problems in terms of connecting these new renewable farms, and we'll get to that in a second. The one thing I also want to mention in terms of the South African energy landscape is the drastic increase in tariffs. So one of the other reasons load shedding has stopped is because Eskom has become exceedingly stricter with allowing their energy to be used without people paying. So in South Africa, we have a lot of municipalities that are in extreme amounts of debt because they have energy and they were allowed energy, but they never paid for that energy. Meaning the customers inside the municipality, the residents, weren't paying their smart meters even though they had access. So now Eskom is starting to really push hard to make their tariffs equal to the energy costs. So how much it actually costs to generate the electricity, they're making the tariff price exactly that, which makes complete sense. But unfortunately, that means in South Africa, there's going to be a very large population that's just not going to be able to afford it. And so there's also this social dilemma that's happening in South Africa with regards to just access to electricity. And although there's infrastructure in place, it's just purely got to do with cost at this point. And with tariffs set to increase almost exponentially, we have very big problems coming unless we're able to very much fast track the transition, which is what the world is looking at South Africa for doing. And if we can fast track the transition, we can have more solar, more wind, and therefore also less cost for electricity, just because the wind and the solar is so much cheaper. Cool. There's another kind of predictions that I wanted to look at. It's just the climate emissions. So we have on the left-hand side kind of our targets that we're supposed to be hitting. And so our emissions are decreasing, but a big part of that is just because of load shedding. But the important graph, I think, is on the right-hand side, where it's just the look of our progress towards renewable energy capacity. So from 2015 to 2024, we've seen very little progress, from about 0 to about 10 gigawatts. But then you see the required installations to meet our carbon emission demand. And yeah, at the current rates, it's just not going to happen unless there's some sort of technological advancement, which is what Asoba is working on. And I believe as soon as that click happens, then it'll open up the markets, and investments will flood in, and we'll hopefully be able to meet this target and show the world how to meet the greenhouse gas targets that we have set within the United Nations. All right, so now let's talk about what the problem is behind renewable energy. Why is it taking so long to install Why is it such a difficult process? And really what's happening. So we've got coal power plants are kind of consistent electricity outputs. They're centralized generators, meaning a very, very large sum of megawatts are coming from one plant. And that plant takes a long time to start up and it takes a long time to shut down. And besides just time, it's very costly for starting up and slowing and shutting down the coal plants. So now, if we have our coal plants connected to our municipalities, we have a max input that can go into our transformers. We have to remember that these equipment and infrastructure is very sensitive. These things can literally blow up. And so there's a lot of regulations in place to make sure that there's the maximum input is never reached. But at the same time, there's also a required constant output. This constant output obviously fluctuates throughout the day. So you've got like your peak times and your off-peak times, but throughout all the days, the graph remains the same. So we need to maintain that constant output, although we have a variable output from our renewable farms becoming connected to this process. So now if our wind farm, all of a sudden in 1 hour, the wind blows very heavily, there's a lot of power coming from the wind farm, you can't just connect that to the transformer, right? Because the coal plant is giving the max output, because an hour before this, the wind farm was producing zero. So the coal plant had to generate all the electricity. So when this wind farm is generating enough electricity, how do we connect it to this already constantly on coal plant's line? And so this is what we mean by a constrained grid. It's very difficult for us to know exactly when the renewable farms will be generating enough electricity so that we can combine it with the constant output from the coal plants. And this is generally the solution is batteries. But as we all know, batteries are extremely expensive. There might be a big drop in battery prices coming up, which would be great, but that still gives us issues in terms of when we discharge the battery, when we charge the battery. It's all these questions of when do we turn off the coal plant and use the renewable farm? We can't just connect the two together and say, okay, this is going to be fine because the coal's constant and then the renewable goes to its max and then the transformer blows up. And so this is why in South Africa, in 2023, we had about just under 20 gigawatt hours of curtailed energy. Curtailed energy means that the energy was generated. So if you consider a solar panel or a wind farm, if the wind is blowing and the sun is shining, those equipment are generating electricity. But if the electricity isn't being used, or if the electricity isn't being stored, then we say that electricity was curtailed, it was lost. And so we've already had in 2024 just under 20 gigawatt hours, no, actually a lot more since it's January to June, of curtailed energy, meaning the energy was generated, but we just don't know what to do with it. And so this is where the choices of when do we turn what off, how do we make our grid a smart grid so that we can actually drastically reduce the amount of curtailed energy and have pretty much all renewable energy used always and have as little dirty energy used as possible. This is where a smart grid and a virtual power plant, which is what we're developing, becomes very important. So just for all of the, I guess, climate activists and energy enthusiasts, the one thing I would really want to push is for people to stop focusing on just building more renewable energy. The renewable energy will come as soon as we have figured out the grid management. And this is where the problem is. As I said, with the constrained grid, we don't know how to connect the renewable energy. So if we focus on grid management, we make a smart grid, we have decentralized energy generation, and we have AI models that optimize our energy efficiency, then the renewable energy farms will just come online because the market is open for it. It's just that the grid doesn't allow for all of the extra generation. And so if we can start focusing on grid management and really enhance and optimize our grid, that's how we end up fixing our dirty energy versus green energy problem. Cool. So what Asoba is focusing on is specifically the software behind such a grid. So we're looking at the AI models for optimizing energy efficiency. So this is what is called a virtual power plant. And so a virtual power plant, the way I describe it usually is, if you know what a digital twin is. So a digital twin is something that you have a physical object, but then you code that object onto a computer so that you can run simulations on it. So a virtual power plant is not a digital twin, it's an active digital twin. So it's coding the entire electrical grid onto your computer, but then also having the ability on the computer to also shut down certain plants at certain times, start up certain plants at certain times, so you have an active digital twin. This is what a virtual power plant aims to do, and there's many methods of getting there, but we're focusing on the kind of center part, which is the AI modeling that's necessary for the instantaneous decisions. But we'll get to that in a second. Cool. So virtual power plant from Asoba side, we're focusing on two aspects at the moment. We're looking at live forecasting, and we're looking at dispatch decisions. So our previous webinar dove into a lot of the details behind live forecasting, but I'll give a little extra background on that in a second. And so live forecasting says, okay, we have our historical data. Can you tell us what's going to happen in the next day? If we're able to know what's going to happen in the next day in terms of what's the weather going to be like for the renewable farms, how much energy is going to be needed by certain projects and companies and municipalities, pretty much supply and demand forecasting, and a whole lot of other additional forecasting as well. We can use that information to make the right decisions. These decisions include stuff like, can we switch off the coal plant tomorrow because we know there's going to be enough renewable energy? Do we need to switch on another coal plant because we know there isn't going to be enough renewable energy? The dispatch decisions that enhance and optimize your electrical grid. So just to give a little bit more background on how our platform works. So we are in between, a nice way to think about it is that we are in between private buyers and public buyers. So private buyers being mines and companies that need electricity, and public buyers being municipalities. We are in between them and the renewable energy farms and the national energy generators. So our platform fits nicely within that mold to say that, okay, if we have the process that we're doing is if we have all of these players signed onto the same platform, then we're able to say, okay, you can turn this off now, you can turn that on there, and you can use AI very much to optimize and really have a high value for your energy traders and your IPPs and smart metering companies and pretty much everyone involved within this new generation of a smart grid. If we can have AI implanted within that, we end up very much increasing profits, decreasing greenhouse emissions, and just increasing efficiency in general. But the real question is, why AI? So in reality, network operators are already using some sort of a similar principle as I just described, to make sure that, okay, they need to know how much electricity one municipality is using so that they can send that much electricity to that municipality. But they're using data science techniques, and this is kind of manually controlled by looking at the graphs. And now the difference between data science and AI, this new revolution of AI, is that AI is considerably more accurate, meaning that data science kind of looks at the trends and looks at, okay, cool, this thing's going up over the space of months, where AI says exactly what's going to happen next second, next minute, next day. And the accuracy is considerably better. It's high precision as well. So data science techniques kind of have to use very intense CPU processes on Google Sheets. It takes quite a while for the graph to be loaded and for the calculations to be done. Where an AI model, if I've trained it over here and I've deployed it over here, this deployment part, you can get your results in nanoseconds. As you can see with ChatGPT, AI is extremely quick with giving you the answers. And so the high precision is also a massive benefit for the electrical grid, because in reality, electrons are moving at the speed of light. So we need to have decisions that are happening as fast as possible as well. We also have feedback loops. So AI can obviously be retrained. So if we train the model on historical data and then we deploy it on the new data, we can retrain it every month till you have even higher accuracy and even higher precision within that feedback loop. And so this all allows for accelerated decision making. So if you're taking a trend data and you're saying, okay, over the space of the next month, this is what's going to happen, so we're going to make a decision in this way. With AI, I say, okay, this is what's going to happen every minute, so I can make decisions every minute, and that makes the optimization considerably better and considerably more profitable or whatever your loss function is going to be. Then beyond that is a modular system. So AI is not just ChatGPT. AI is not just one model. AI is something that is building up and up and up. If we start in the middle, in our regard, we start with forecasting. We can take that forecasting into dispatch decisions. We can take that dispatch decisions into reinforcement learning. We can take that reinforcement learning, et cetera, et cetera, et cetera. As the research is increasing, we can have a modular system that builds up and really becomes one of the big players and kind of the big brain of the electrical grid, if that makes sense. And then besides that, it's just your competitive edge, right? So AI is the new buzzword. We as Asoba are very, very professionalized in AI. It's not the right word. We're very clued up in AI or educated in AI. So having that competitive edge now, sooner rather than later, AI is going to be everywhere. AI is going to be used everywhere. No one's over exaggerating when they're saying that. That is the truth. And so having that competitive edge as quickly as possible for your trading, for your optimization, is also crucial. Cool. So now in terms of Asoba, so we are AI and data science professionals. We're combining techniques to give customers an opportunity to train their own custom AI model. So instead of ChatGPT, which is just one conglomerate model that the whole world is using, we're taking a different angle and we're saying, give us your data, not give us your data, but send your data to our training code, and then we will train a model that is specific to you. Is your custom model trained on your data that isn't accessible by anyone but you? And so we're making this accessible through an API, and I'll go through a demo in a second. But yeah, the solution allows for, on the data collecting side and the data science side, enhanced data collecting schemes. So we've got partners that allows for very precise and consistent data collection through advanced decentralized cloud systems, which is also a lot more efficient, energy efficient than centralized cloud systems. We've also got then real-time data monitoring, and this is where AI comes in. The data comes in, and it's in real time, and we're allowed to, because the AI is so quick, we can have real-time analytics on that model, or on that data, sorry. And then through that, our models are doing forecasting and dispatch decisions, which are the two specific things we're targeting at the moment within the energy sector. But of course, more is to come as well. Cool. So just to give a background of our forecasting. So at the moment, we're forecasting for several users, including energy supply and demand. So how much energy is being generated and how much energy is being used at different levels. So all the way from residential to municipal to national generators. We're also forecasting carbon emissions. So that we can include that within our loss function of our virtual power plant. The end goal is electricity for everyone, but the end goal beyond that is green electricity for everyone. And so predicting carbon emissions to reduce that is also a big player. Water supply and demand, we're also forecasting price, and then pretty much anything else that is necessary. Cool. So just wanted to give you guys a demo of how this exactly works. I'm going to have to switch to my entire screen. So we're busy partnering with AWS. We've got we were awarded the Climate Fellowship by AWS. So they're helping us develop our proof of concept and giving us free credits and working very much as a partner with us to develop this AI system within their cloud. So at the moment, we've got the training of the forecasting completely streamlined and the inference thereof. So I just wanted to show you guys exactly how that works. So over here, we've got a kind of a directory or an S3 bucket if you're a bit more versed in this. And if we look at historical data, we end up with all of our clients. And if I just go into here and I drop off the data for a specific client. And so, for example, it's taking a bit slow over here. But if I drop off the data for a specific client, then that triggers the training job for that client. This might take a couple of seconds for the data to upload because it is very large data. But the nice thing with working with AWS is that it's such a big infrastructure, cloud infrastructure. We are able to train massive models and upload massive amounts of data as is necessary per client. Anyway, so as soon as this data is uploaded, the one thing as you might notice at the moment is that I'm just manually uploading it. So we're working with all of our clients to have a handshake of data transfer. So there's going to be two options for people to transfer their data. On the one hand, people can just upload it directly through an API, which we've also developed, and that puts the kind of control in the user's hand. They can upload their data, they can control exactly what's happening instead of just sending the data to us. But there's going to be some problems in terms of the data structure and all this kind of stuff that does occur with that. So there is another option as well. And before I get to that other option, so this data was now uploaded over here, and then you'll see on the training jobs, that's the date, the training job for that specific data set has started, and that usually takes about an hour or so for about 25,000, or was it 200? It was 250,000 rows worth of data. It takes about an hour or so for the job to finish training. But over here is one of the older ones that I did finish training just yesterday, and you'll see all of your kind of output from the model training. So there's different epochs that happen, and then there's different validation metrics. So we're using mean squared error. And so after the hour, you end up with after 50 epochs, which takes about an hour, you end up with a model that has, in this case, a mean squared error of about 0.22, which is actually considerably more accurate than most data science techniques that we have experimented with. And so we're very proud of this model, and we think this is going to be one of the go-to models for forecasting in the future. Just to give a little bit more background on the model that you are training for yourself, it's called a generative adversarial network. It's very much, you can consider it the same type of style as a ChatGPT, where ChatGPT forecasts the next word. This model forecasts the next whatever you're forecasting. And so it's very similar, but it's using very advanced state-of-the-art AI, with the R&D department also consistently improving this model as we go along. In any case, so if your data is finished training, or your model is finished training on your data, you'll end up with a whole bunch of e-discovery data points. So exactly what we trained the data on, what we tested the data on, different trains that we use, and then eventually your model as well, which allows you to infer from that model. So now with this model trained, the question is, okay, how do I get the forecast for it? And to do that, again, we look at a data handshake in some way, and I'll get to the second method in a second. But again, the data gets uploaded. As soon as the data is uploaded, the data upload takes about a couple of seconds, because you're not giving historical data anymore. You're just giving the last week's worth of data, and that goes into the model, and then the forecast is generated. And this can take up literally less than a second. And so the data was uploaded, and so now over here you'll see your forecast is dropped off as a CSV, and this is the data that was passed through the model. And so this entire process is streamlined, but as I said, the uploading of the data, that is specific to the client. So again, you can either send the data to us and we can upload it manually, as I just did, or you can use our API to upload the data, which we've also developed, and that's going to be sending an API key to customers so that they can upload their own data. But again, the inference part, that becomes a little complicated for a lot of users. And so what we are also working on is an API that allows you to send an auth token or authentication token to us so that we can download and manage your data for you. And this is preferred for us because it does give us a lot more control. The data is anonymized, all that kind of stuff. The data privacy concerns are all dealt with. But in terms of downloading the data and getting the data in the right structure and getting, it's called data globbing, getting all that in the right structure, that we put onto ourselves because we are professionals at that, and we've done it a few times now. And then that job is not on the clients anymore. And then we can send out forecasts pretty much on a scheduled basis, or even on a push button basis. Cool. So that's the forecasting in terms of the AWS, how we're using it, and where we're going with that. Cool. So now with forecasts, the next point is the dispatch decisions. So if we have forecasts, if we know, okay, there's going to be this much energy that's going to be used in the next day, and we look at it in terms of a time resolution of, say, half an hour. So at the moment, we're looking pretty much at half an hour time resolutions, but that can also change. Sorry, one other point in terms of the forecasting is that the time resolution is, we can choose it. So it depends on obviously the historical data that you have. But if you have 1 minute historical data for the last 5 years, but you only care about the last month's, every month's worth of forecast, we can change the AI model to only forecast every month instead of every half an hour. And so that's a very unique part of AI as well, is we can very quickly and easily change the setup of in terms of the input and the output that comes out of the model. Cool. So, but if we consider our kind of base case is that we look at a 30-minute interval, we have energy supply and demand predicted over that 30-minute interval. Now we can start making decisions on those forecasts. Specifically, we can have kind of connections to smart meters or to smart controllers, or to all kinds of devices that's kind of manage the grid. And then within that meter, we can say, okay, we know that there's going to be in half an hour's time, we know there's going to be an excess amount of energy coming in due to wind or due to solar. So you can switch off maybe your battery, or you can switch off your dirty energy, or whatever decision is available to that specific device, given the forecasts that come in handy as well. And that allows enhanced decisions, enhanced optimization, as well as a custom loss function. So every client it can also have their own custom loss function in terms of maybe you want to decrease your greenhouse gases. That's kind of a very strong research loss function. So then we take in all the factors and we say, okay, with knowing what's going to happen in the next half an hour, we always want the dirty energy to be as little as possible. And so the model is able to understand that and make that work within its decisions. Or if you want to have the highest profit, so we're working with a lot of traders as well, and you want to say, okay, we want to sell this energy at the exact time that's going to give us the most amount of profit, all while maintaining our licensing and our contracts, you can have your loss function in that regard as well. Cool, but then the other cool part about the AI models is it can integrate very easily with all the different infrastructure, as I mentioned, and that allows us to make these instantaneous, extremely accurate, extremely optimized decisions. Yeah, so in terms of the different models that can be used as well, so we've got history with swarm intelligence, evolutionary algorithms, Bayesian optimization, all under what we are predicting is going to be the most optimal model is a reinforcement learning model that kind of learns how to play the electrical game. As long as we've got that digital twin, we can train the model under a reinforcement learning paradigm based off the custom loss function to just make the most optimized solutions that is physically available at that specific point in time. But obviously, this is going to be dependent on the client and the handshakes of the data and all kinds of extra stuff. And the more players we have involved within this AI model, the more things we have connected to this AI model, the more optimized and the better and the faster we can evolve our grid into really a smart grid that is worthy of the research and the technology that our human race has already evolved to, except we just can't, for some reason, seem to mass produce any of it. Cool. So just in terms of an industry use case, so independent power producer, as the webinar said, the enhanced decision. So if we have this AI model and we fit into the middle points between the constant output of the coal plant and the renewable farm, we are able to say to the renewable farm exactly when it should release its energy, when it should store its energy, where it should release it to, as well as looking at the coal plant, when should the coal plant lessen the amount of electricity it's producing, and all this extra stuff that plays a very big role in terms of the constrained grid and getting rid of that problem where curtailment of renewable energy, really we're just losing energy. We're spending a lot of money, and really these renewable energy sort of equipment have lifespans. And so us losing energy and not using that energy is just ending up with wasted money, because after 30 years, you're going to have to replace it, but you only got 10 years worth of energy out of it. And that's just a complete waste. And so for us to have our AI model within this setup to say exactly when should the renewable energy farm store its electricity into the batteries, release its electricity to the municipalities, et cetera, et cetera. That's how we can optimize and really be a game changer within this new smart grid and take away this concept of a constrained grid so that we can really end up becoming the smart green energy that we all wish to have. Cool. And just to give you guys a little bit more in-depth look at kind of the forecasts and the dispatch decisions. So over here, we're looking at a small scale embedded generator. So that's anything underneath a 1 megawatt that has solar power and batteries within it. And where we gave it the historical data for this SSEG, and we are asking our model, please forecast how much electricity this user is going to need, how much electricity the solar panel is generating, and whether there's load shedding or what's the grid tariffs and all this kind of stuff as well as part of the forecast. And so you can see the first column over here, gives us how much energy is being generated by the solar panel farm. And obviously in the middle of the day, it's quite a sunny day, is the most amount of power that's being generated. And then we also predict the load active and the load reactive to say how much energy is the user using at any given point in time so that we can make our decisions based off of that. And so these forecasts, were at half an hour intervals. So this is the day ahead forecast. So if we were at 2021 on the 15th of the 8th month, we are predicting for the next day. And so then the next day we can also make various decisions. So we've got code that's written out and optimized to say that, okay, we want this exact amount of energy to go from the solar to the load. So from the solar panels directly to the user for using at every half an hour, we know exactly how much we want. From the solar to the grid, so there's an additional factor of selling back solar energy to the grid so that you can make a profit. And I'll touch on that in a second. From the grid to the user, so just from Eskom to the user, but obviously if the batteries are maintaining the power, then we can have quite a lot of half an hour intervals where we don't use any energy from the grid, but only if we have optimized it in this regard. And so grid to battery 1, so to charge the battery 1 to load, so battery to the user, grid to battery 2, so if you have more batteries, we're also able to handle that. And so for every half an hour, we know exactly how many kilowatts, how many megawatts we want to send where. And so these forecasts and these decisions can help us optimize and fully optimize our use of energy within this system. The one thing I do want to touch on quickly is the solar to grid. So we've worked with a few pilots where selling back your energy to the grid is becoming a major player within South Africa. So in terms of the renewable energy mix, you've got these large IPPs that are coming online, but the grid is constrained, so they're struggling. And so a big player, it's not going to be enough, but it's going to be a big player, is just residential or company small scale solar panel farms, so anything under a megawatt again. If they have that solar panel and possibly their batteries connected and they have excess solar. So again, we're even at a home with solar panels on your roof, there's a lot of energy being curtailed because you're not using the energy. And so to sell back that energy to the grid is now becoming possible as well. And we've seen people end up with almost a 40% saving of their electricity bills because they're selling electricity back to the grid, which is, you can consider it as like very small scale wheeling. And so Eskom has got this whole platform where they can pay you back your credits if you sell back certain amounts of power. And we've worked with municipalities that are also signing this in within South Africa so that we end up having municipalities that are kind of could one day, at least this is a dream, at least for small municipalities, definitely completely be off the grid. They can contain themselves within that municipality and because they've got all this power being kind of sold in between all the users and the people with the solar panels and the batteries available inside that municipality. So yeah, that's also part of our optimization scheme, is to sell back energy to the grid and have that additional profit and incentive for the different users. Cool. So just as a conclusion, the GDP and the CO2 emissions across the world has always been kind of positively correlated in terms of as the GDP goes, as CO2 emissions go up, so does the GDP. However, there's a very big change happening in the world where GDP and CO2 emissions are actually becoming negatively correlated, meaning GDP goes up if CO2 emissions go down. And this is because of this whole energy transition that's happening in the world, where really we're trying to spend our money on green energy instead of dirty energy, and the people with the most amount of money are able to do that the most. And so we end up seeing a negative correlation. So in Africa, we want to take the same step. We have a very, very beautiful and extremely important economy in terms of in terms of ecosystem in Africa, in terms of all the nature. We can't destroy this nature, otherwise really the whole world might actually die. And so we want to end up taking the same path as what the first world is doing, where CO2 emissions are going down, even though GDP is going up. And so we have this opposite correlation happening within the world. And Africa is certainly able to, with all of the sun that we have, with all of the wind that we have, we are certainly able to not just do this, but possibly be the world leaders within the space of really becoming a green economy. Cool. And so Asoba wishes to place ourselves within the sector by implementing AI for the most optimized versions of selling green energy, and really becoming that smart grid player and being the AI model within that smart grid, so that we can really focus on grid management first before we end up focusing on building more renewable energy generators, because without a grid, we can't use our renewable energy in the first place. Yeah, and so that's again about us. We want to 100% electricity across Africa, and we're doing that by optimizing the renewable energy space and the smart grid technology behind it. Cool. I think, yeah, that's all from my side. If anyone has any questions, I have a couple of questions that are kind of planted as well. If there are any questions from the Asoba team or any of the other listeners, if there are other listeners, please go ahead now. Nope. All right. There's going to be quite a slight edit. I'm just going to Chiwo's questions. Going to answer some of them. Give me 1 second. So one of the questions that are constantly regularly asked by us, especially by the engineering firms that we're working with, are like, what are the current limitations of connectivity to smart devices, and how can we overcome these? So smart devices are very much devices that we're generally using. So for example, the meters outside of your home measures how much electricity you're using or how much electricity is being generated. But putting smart in front of that, so to make it a smart energy meter, means that we have consistent connection to that meter. So that data is being collected on possibly a second basis or a minute basis, but we also have direct access to that data every minute as well. And that's very important when it comes to the smart grid technology, because really we need to be able to instantaneously zoom in on these devices and tell them what to do. Again, with the dispatch decisions, we need to be connected to these devices so that we can end up saying this is the most optimized thing to do. So the biggest limitation is getting that connection really sound. Inside cities, it's not really a problem because we've got quite good connectivity telecommunications infrastructure within the big cities. But when it comes to the rural areas, this is going to be quite a challenge in terms of getting connections from those devices when there isn't really good signal in the first place. But we do have solutions for that, specifically looking at edge computing solutions. And so instead of sending the data to a cloud somewhere in a city far away, we can have a decentralized cloud system there by the rural area, so that the data is only transferred there close by. And so you end up with kind of your own mini telecommunication infrastructure within the smart space so that we can have that constant communication still happening. Cool. Can you elaborate on how the API facilitates autonomous dispatch decision within a decentralized grid? So again, touching on that same principle, if we have smart meters that are connected and instantaneously communicating with us, we need a way for our AI models to communicate with them as well. And that's why we have an API really built for direct communication between where our AI model is stored and that device. And so we end up having that connection through the API. So API is extremely important for this smart grid technology because of how all these things are communicating with each other in the first place. A couple of other questions maybe before I close it off. So how does the ability to execute decisions autonomously give IPPs a competitive edge over traditional methods? Again, as I mentioned, the whole benefit of AI is this instantaneous, high accuracy, high precision model that allows you to make decisions now. So it's not sitting there and kind of looking at the data over the next month and saying, this could be the best decision, this might not be that kind of stuff. It's saying, okay, we have a model that tells us exactly what the most optimized decision is going to be in the next second. And so let's make that decision for the highest profit. And having that competitive edge is going to be extremely important for all IPPs, really to stay on board of the day ahead trading or eventually the live trading of energy and electrons. Cool. I'm actually going to call it quits there, seeing as there's only about 5 minutes left. I hope everyone enjoyed that talk. This is what we are building. This is what we know. Oh, maybe a question from Gertie before we end it off.
I have one question. I just wanted to find out if the forecasting tool can be deployed as a service to a single user. And by single user, I mean a small house, say a family of 4 or 5, with a certain amount of production per month. How will that integration take place? And is that a service that the forecasting tool can be deployed for use?
Yes, 100%. So as I mentioned in the demo, there's kind of different ways on how to deploy the data within the forecasting system. There's kind of give the user control. They upload their data and they've got complete control over how they use their model. But then there's the less hands-on method of giving access towards the data. So if you're talking about a residential home with an inverter, as long as the data is being stored and we have access to that data, then we can connect it within our cloud system and our AI system to collect that data and on a regular basis, first train the model on that data and then on a regular basis send out the forecast to the inverter. Now, there's still, again, a little bit of a hands-on or hands-off kind of scenario as soon as the forecasts are sent, because we can have dispatch decisions directly connect to the inverter to say to the inverter automatically, please do make these decisions, as I showed you in terms of these decisions. So please do exactly these decisions on a live basis. Or there's the additional option of giving the user a bit more control and sending out our predicted forecasts and our predicted decisions to the user, and then they can decide how to use it. But yes, certainly available for anyone who is generating their own power or even using their own power. Doesn't matter in terms of size. So IPPs is an independent power producer, which means it's a very large scale kind of project, but an independent power producer could also be a residential home, as you said, with solar panels on top of their roof. And so the exact same principles apply, and the exact same profit margins can be made in terms of that selling the solar power back and optimizing your energy efficiency, so to decrease your ESCOM bill as much as possible. Beautiful. Cool. Thank you everyone for listening. Thank you for everyone for entertaining. And please join us for our next webinar next year. We do not have a date yet, so please do check our socials. But yeah, that's pretty much our year in a wrapped up in a nice presentation. It's been one hell of a year, and we are excited to further develop our solution and really make this world into the world we want. Beautiful. Thank you, everyone.